This is a MacBook that came in for no power. I already have the board out, and the particular thing about this one is that when you plug in the charger, it actually gives you a green and orange light, which means that the board is partially alive. After this, I'll start checking all the main voltages that are supposed to come on before anything else comes on, and they come on as soon as you plug in the charger. They're all present, and I'm writing down the results on my notebook as I go along. So since everything else was present, all the first rails that are supposed to come on are present. I started checking the S4 and S3 power rails, and when I was checking PP5V S3 here, the capacitor I was taking the measurement on got ripped right off of the board. I barely put my multimeter probe on it and it came right off. And that's this capacitor right here. The traces were completely charred, and the capacitor itself, which I'm testing here, was totally shorted. It's a dead short. That's why it came off so easily, because it was charred and it was brittle. So this is after I cleaned up the area a little bit. I had to do some trace repairs and rearrange everything, but this is the circuit with the new capacitor in place. After this, I'll just add some solder mask and put it under the UV light so it cures. And while that cures, I'll clean up the heatsink here and put new thermal paste on everything. I'll get the board off of the UV light, and I'll show you what the solder mask looks like once it's cured. So everything's looking perfect. Now I'll just clean off the solder paste off of the board side, and look at that beautiful before and after shot. I like to spread the thermal paste myself, and I don't like to use one of those patterns that you press on with the heatsink. The hardware test passes with flying colors. Unfortunately, when you start to boot up, here's what happens. Watch, it boot loops. So now we have one additional issue, but we know that the hardware test passes, and when I boot it into Ubuntu, everything works perfectly in Ubuntu. Every control, every key, nothing seems to be wrong with it in Ubuntu, so we can deduce that this issue is a strictly software issue. The last thing I did to the hardware side was replace this little latch for the fan connector. I took it off of a dead motherboard and put it on this one, and everything else got put back together, cleaned up, and we got done with the hardware. Last thing I did was replace some of the back cover screws that were missing. I had some spares, so I put them in, and then we can go and deal with the software issue. Now this is the recovery utility on Macs, and I ran the first aid thing thinking it wasn't going to do anything, and in fact it didn't seem to do anything, but it actually worked. For whatever reason, it fixed it, so I'll take it. I'm happy. This once dead Mac is now a happy and alive Mac, and it looks beautiful now. Follow Computer Prodigies for more. This MacBook is having issues with the webcam. It doesn't appear at all, so we're going to try and diagnose the actual webcam power circuit. A quick visual inspection immediately showed a burnt IC right here. Up close, that's what it looks like. That isn't actually a capacitor, it's an inductor, and it carries the 5 volts to the camera. So we're going to go ahead and clear this short, remove that without lifting any traces. I think I'm going to cut here and clean all this other stuff up, and then solder the new inductor to that. Next, we're going to use a little bit of this informal coating, and we're going to apply it to this area. And now we're just going to put this under the UV light for a few minutes. In the meantime, we're going to source the inductor from this junk board. The solder mask is now dry. We're going to go ahead and fix up the pads, put on the new inductor. I'm also going to end up replacing the capacitor next to it because it did get damaged from the flame. Source the connection for the inductor here since we lost the pad. It should be good to go. Before we assemble everything 100% of the way, I'm just going to go ahead and test first. So as you can see, the camera is now working. We're just going to clean it up really quick and she'll be all done. This is a MacBook that came in for light liquid damage, and even though it still turns on and everything still works, the customer still wanted us to check it out since they did have something spill on it. So I do see some very light liquid damage around here, some very light liquid damage around here. You can see it clearer here on the microscope. There's a little spot right here, and it may have gone underneath the shield. On the back side of the board, we also have some liquid damage around here and around here. This is what it looks like underneath the microscope. It's not too bad, thankfully. The only capacitor that seems kind of damaged is this tiny one right here, and then there's also some corrosion around this here, and this IC as well has some corrosion, and then this IC here also has a little bit of corrosion, but nothing too bad. It's actually not too bad at all. The customer did the right thing by bringing it here before using it more. So we're gonna remove all these covers on the shield. It'll help with the drying process. Also remove the heatsink so we can drop this in the ultrasonic cleaner. So since the liquid damage isn't too bad on this one, we're not gonna run it for very long. And you can still see some residue. Some of the stuff sticks really well. So I'm gonna go ahead and do a quick pass using alcohol and my toothbrush. So that looks pretty good now. Didn't come off with the ultrasonic cleaner since we used it for only like 15 minutes. Here's this IC here. So I was debating whether or not to reflow this IC since nothing's actually broken, but since I see that there's still corrosion around, I'm going to go ahead and reflow it. I hate doing this kind of stuff on anything that works because you're always risking breaking something that wasn't broken before. Alright, so this IC has been reflowed. Everything looks nice and clean now. So the other spot that was a bit of a concern to me was this capacitor here. The end cap on it is corroded. You can see the dielectric material through the end cap, so it needs to go. Alright, so I found the capacitor in the schematics, C7752. It's a 0.01 0201 package. So the other area of concern was these two ICs here. I see some corrosion along the edge here. It might break down the road if we leave that corrosion there. So I think it might be a good idea to give this a quick refill. Alright, so we're going to try and do a test. Alright, so far so good. I'm trying to make sure there's no missing screws at all, no missing connections, nothing. Everything looks good. Alright, so I think everything's good to go. We'll just call up the customer after doing some final testing. I'm waiting for the password so we can test out the whole keyboard and everything. But everything seems fine. We just basically did preventative cleaning so that there wouldn't be any issues in the future. Today we're going to be working on this MacBook Air. There is no power. The charger light doesn't come on either. And this thing is completely full of roaches. So the battery's been disconnected. Somebody was already trying to test. So I definitely already see some corrosion right here close to the SMC. Alright, so inspecting the board, there's really only two main places that have been damaged from the roaches. One of them here, and it kind of looks like some kind of liquid was dropped down here near the EEPROM. And then the other place is near the SMC. You can see this is pretty bad right here, and definitely a lot of roach poo around the SMC. I'm not sure why they like hanging out around that the most, but we're going to give it a good cleaning. Hopefully there's no corrosion underneath the SMC. As far as I can tell by looking under there with the microscope, there doesn't seem to be any corrosion underneath the SMC, which is pretty good. So let's start cleaning. So in this case, I'm not actually going to do a full-on ultrasonic cleaning. I'm just going to give it a quick scrub down with this cleaning liquid. Whatever processes you don't need to do, we try to avoid to reduce the risk of something going wrong. And in this case, there's just roach droppings on a few places of the board, but I'm just going to give it a quick scrub over. And we shouldn't really have to worry too much about there being anything underneath. Alright, so after that, I'm going to clean with alcohol to remove the residue from the previous liquid. Little daughter board also seems to be okay. I'll give it a quick pass with alcohol just in case. I'm surprised that there isn't more droppings. I'm just curious to see if it's going to work now that it's been cleaned. Some of the corrosion has been taken off. And yeah, sure enough, we have a charging light. So I'm just going to go back really quick to near that SMC area, because I remember seeing one resistor that looked really bad. So I'm going to try and take care of that resistor, if it even needs it. Here's the two resistors near the SMC that are looking a bit tarnished. So the pad underneath that resistor right there looks pretty bad. I hope I'm going to be able to solder to it. For this, I'm going to use a little bit of acidic flux. Alright, so our pads seem to have been fixed. I was able to return them. I gotta make absolutely sure that I get rid of all this plumbing flux because it's very acidic. Alright, so here's our pads. This one for the resistor on the left here mostly got eaten away. You can see there's only a little bit left of it, but that should be good enough to solder the resistor to. So we're gonna take this donor board right here, and this will have the resistors that we need. We'll do those one by one. You can see this one resistor is wanting to stand up. I think it's settled down to that little piece of pad. It should be making connection and everything now. When I heat this thing, it definitely smells like cooked roaches. It's pretty awful. Alright, that should be fine. So I'm going to put this back together and see if we have fan spin as well. Earlier we saw a charge light. Let's make sure it's still showing that charge light and also doing fan spin. Usually as long as it does that, it means it's good to go. Alright, charge light and fan is spinning. Okay, let's power it on. We have charge light, you can see the screen turning on, and we have login screen, so this should be good to go. Let's do a hardware test. So right now we're just going to let this hardware test run. It's going to make sure everything on the motherboard and the computer is okay. Hardware test has passed, no issues found. So this laptop is all done. Ready to call the customer to come and pick it up. Thanks for watching the video.